Um, Today's topic is glycolysis. So, what is glycolysis? Glycolysis is a central metabolic pathway. It involves metabolism of a sugar molecule called glucose. This slide shows us an overview of the process. Okay, it can be divided into two phases. The yellow box out here, it shows us at the first phase, a phase in which a 6-carbon intermediate is broken into two 3-carbon molecules, and the ADP energy is invested. The second phase is here. What does it show is that these two 3-carbon molecules are used to generate the ADP. Okay, the starting point of glucose is the glucose molecule out here, and the end product is pyruvate. Additional products involved here are NADH and ADPs. This is the first step of glycolysis, involving the enzyme hexokinase. Glucose is converted into glucose 6-phosphate, G6P. Now G6P has a carbon, this 6th carbon of G6P is phosphorylated by hexokinase. It's a kinase enzyme. It uses ATP as the molecule which provided with the phosphate to add it to the glucose molecule. You might keep this in mind that hexokinase doesn't only act on glucose exclusively, it acts on other 6-carbon compounds as galactose, mannose, and fructose, etc. The next step here is an isomerization step. This glucose 6-phosphate is converted into fructose 6-phosphate. Now the enzyme is phosphoglucoisomerase. Keeping in mind that these steps will only help us to understand that this aldehyde group is converted into an acetone group by that enzyme. Now the next step is a very important step. It's a regulatory step of our glycolysis, and the regulatory enzyme is phosphofructokinase. Yes, PFK1. I will abbreviate phosphofructokinase as PFK1. Okay, now PFK1 actually acts on this fructose 6-phosphate and convert it into fructose 1,6-bisphosphate, and actually what happens is that there's an additional phosphate molecule being added to the first carbon of the fructose F6P. So this step gives us a compound. Now this we should keep in mind is a regulatory step. So this enzyme is actually regulated by some molecules. Few of them I will mention it right now is that keep in mind it's a regulatory step. Okay, and the second point is that I will show you what are the molecules or how this enzyme is regulated in the future slides. Now F16BP is converted into DHAP, dihydroxyacetone phosphate, and glyceraldehyde 3-phosphate, GAP, by the enzyme aldolase, which actually just cleaves the molecule into 3 carbons. This marks the end of the energy investment phase, or where the 6th carbon is converted and cleaved into 2 3-carbons. And another thing is that this also ends our first video. I hope you like the video and you will subscribe my channel, and I hope you find it helpful.